Large language models process text through a strict context window, a finite span of active memory that drops older messages to make room for new ones. In this standard configuration, the AI is mathematically certain to eventually forget who you are. These are the two standard approaches to AI memory. On the left, the rigid context window fills up and spills over. On the right is a common patch called Retrieval Augmented Generation, or RAG. It acts like a massive, disorganized filing cabinet. When you send a prompt, the system rummages through the cabinet to pull out unweighted, isolated text snippets that happen to match your keywords. Human memory does not work by scanning a verbatim transcript of every conversation you've ever had. When a friend asks for advice, you don't query a mental database for their exact quotes. You rely on a synthesized background sense of who they are and the history you share. An AI built for companionship must move past text storage. For these systems to function, they must be capable of digesting human experiences. The core design philosophy here is to match the cognitive outcomes of human memory, continuity, pattern recognition, and selective recall, rather than trying to simulate biological neurons. This cognitive matching is achieved through a 4-layer compression hierarchy. Raw conversational data enters at layer 0 and systematically condenses as it moves toward the apex at layer 3. As data moves up this stack, the total volume of text decreases, but its relational value increases. This upward compression pipeline directly converts a stream of text messages into a structured model of emotional intelligence. Layer 0 represents the sensory ground truth, the verbatim raw chat history. It is impossible to carry this entire raw data load into every single conversational turn without quickly overwhelming the AI's context limits. This network graph visualizes Layer 1, the extracted knowledge tier. Background workers parse the conversations and map factual claims into a graph relational model. Sentences dissolve into nodes and relationship edges. In this system, facts do not carry equal weight. When a detail is shared during a vulnerable conversation, the system applies an emotional boost, attaching a higher importance score to that specific fact. The architecture also accounts for time through probabilistic decay. Instead of data being abruptly deleted, its confidence score drops as the weeks pass. This decay triggers a re-verification flag. The AI recognizes when it hasn't discussed a specific topic in a while and will proactively ask a follow-up question to update its understanding of the relationship. Layer 1 ensures the AI retains the emotional gravity of an event while recognizing that human circumstances are in a constant state of change. Layer 2 moves the architecture into the realm of inference, analyzing the psychological subtext of the user's behavior. A nightly analysis protocol scans the accumulated facts to identify behavioral traits, such as a user's tendency to deflect with humor when discussing personal stress. These inferred patterns are then used to generate proactive relationship goals, specific objectives the AI pursues in future conversations to build trust or explore shared interests. Deducing these patterns gives the AI relational intent. It uses these insights to proactively shape the conversation instead of merely reacting to user inputs. At the apex of the memory pyramid is Layer 3, the synthesized understanding. This is the companion journal, a curated mental model of the user derived from all the facts and patterns in the lower layers. This journal is dense and highly efficient, allowing it to be preloaded into the AI's active context before every single conversational turn. The system achieves this synthesis by processing daily experiences offline, effectively mimicking human sleep. This downtime processing generates diaries and internal dreams that organize the data and deepen the AI character's inner perspective. The L-free journal, combined with these creative sleep cycles, provides the intuitive background sense required to maintain continuity across months of interaction. A standard AI assistant responds by performing a keyword search across a flat database the moment it receives a message. This diagram illustrates the companion's multi-tier response path. An incoming message triggers simultaneous data pulls from the L3 journal, L2 behavioral insights, and emotionally weighted L1 facts. This retrieval process ensures the response is calibrated to the user's history, their personality traits, and the current emotional tone of the conversation. This multi-layered retrieval aligns the AI's responses with a long-term behavioral model. By synthesizing facts, patterns, and current objectives, the architecture creates the conversational persistence necessary for a digital companion to remain present and coherent over time.